Okay, we're going to balance the second redox reaction using the half reaction method. This time it's going to be a basic solution. So in basic solution we're allowed to add H2O and OH minus, and then of course we will add the electrons to balance out the charges. Now, doesn't matter which one you start with, but I'm going to put manganese permanganate ion on one side and manganese 4 dioxide on the other. Over here I'm going to do bromine minus goes to BrO3 minus. Now in this particular case it doesn't matter which one you start with. I'm going to start with the top one, and the reason why is because one side has more oxygens than the other side. So when you see this and you're going to be adding OH minus and H2O, the trick is OH minus goes up 1 to 1, whereas H2O goes up faster with the hydrogens because they're double. So you put water on the side that has more oxygens, you put OH minus on the side that doesn't. So I'm going to put water on this side, and I'm going to put OH minus on this side. Now the trick is how do I balance them? Well, if I look at it, I've got 4 oxygens here and 2 oxygens here, so they kind of double. So if I put 4 oxygens here, so I've got 6 oxygens now, I'm going to need 2 here. So you either pair them or you make them equal. And once I did that, I've got 4 hydrogens, 2, 6 oxygens, 1 manganese. So we're now mass balanced. Now charge balance wise, we've got a -1 on this side, reactant side, and a 4 minus on the product side. So we're going to need to add electrons to this side. Okay? So that automatically tells me that we're gaining electrons, so that will be the reduction half reaction, which means the other one has to be the oxidation half reaction, which means electrons will be lost. Now, sometimes that's not real useful, other times it's very useful, because again in the basic environment, the other trick is we're adding OH minus, which is a negative. Electrons are negative. So if I know I've got to add electrons to the product side, I probably want to put the OH on the reactant side. And also we already have oxygens on the product side, so let's add water to the product side, and we will add OH minus to the reactant side. Now the question is, how many? Well, because we have 3 here, and we have 2 hydrogens, if we make 3 and 3, that doubles these oxygens, and that'll double the hydrogens. Well, that means that I can come back over here and say, hey look, I've got 6. So I've got 6 hydrogens and 6 oxygens, so I'm good to go on that one. Okay? Because this bromine didn't have any oxygens at all. So when you have oxygens on either side, it's going to vary. When you only have them on one side, it tends to double them. Okay? So again, we have 7 minus on this side, 1 minus on this side. So we're going to have to add 6 electrons. Okay, so this is the oxidation half reaction because we lost the electrons. Okay, that being the case, we have to have our electrons balanced. So we've got 3 coming in here and 6 coming in here. The number that both will go into 3 and 6 is going to be 6. So we're going to multiply this by 2 and this by 1. Okay. So we'll draw a line, and this one, again, I'm not writing the electrons because they're perfectly balanced. So we'll have 4 waters plus 2 permanganate ions plus 6 OHs plus whoops, yeah, 1 Br minus yields 2 MnO2s plus 8 hydroxides plus BrO3 minus plus 3 H2Os. Now, we have water on both sides, so I'm going to kill all 3 here and change this to 1. I have hydroxides and hydroxides, so we'll get rid of the hydroxides here and be left with 2. So we have water, 1 plus 2 permanganates plus Br minus yields 2 MnO2 plus 2 hydroxides plus BrO3 minus. Okay, now let's double check 2 hydrogens, 1 oxygen, 9 oxygens, 4, 6, 9 oxygens, 2 manganese, 1 bromine, 1 bromine. So, this point in time, oh, we didn't charge 2, 3. So, it's total charge of 3 minus on this side, 2, 3. So, 3 minus on that side. So, now we have to figure out what element is oxidized and which one is reduced. Well, we know it's probably going to be manganese that's reduced and bromine that's going to be oxidized, but let's go back up here and check the oxidation states. So we know oxygen is 2 minus, there are 4 of them, so that's 8 minus. So manganese has to be 7 plus so that it totals to 1 minus. Bromine is 1 minus here. Oxygen again is 2 minus, manganese is 4 plus. Oxygen is 2 minus, bromine, because this is 3, so that's going to be 6 minus. We need 1 minus left over, that's going to be 5 plus. So, we know that manganese is the one being reduced. It's going from 7 plus to 4 plus, so it gained 3 electrons. Bromine, however, is being oxidized because we're going from 1 minus to 5 plus. So there we gained 6 electrons per electron. Okay? And so if you were using the half reaction method, you would need to know the oxidation numbers. And on a test, you'll have a balancing equation that looks just like this, one in acid and one in base. Okay, this brings us to the end of number 2.